So I went over lists a little bit in the data types and structures, and I kind of punted a little bit when I went over this. So I said that lists would make more sense to you once you understood what indexing was. So now I'm actually coming back and explaining that, and hopefully this will help you understand what lists are. And then I actually gave a practical example of where you would use lists. Because that's one thing that I've gotten feedback in the past. It's very abstract with lists, and it's hard to conceptualize what you would actually use it for. So I do have an example of that, although very simple. So a super simple list. If you go back to our previous classes, we have talked about lists and how they're different from vectors. So if you have a vector, so if you had a C here, you would have to have every single item in your vector would have to be of the same data type. If not, it will force it to be the same data type. You can't have multiple, like say a string like you have here. It has a numeric variable or an integer variable here, and then it has character values here. So we got numeric character value, numeric value. If you try to do that with a vector, it's going to force this to be a character value. Maybe you don't want that. So lists would be the best thing to use for this. So this is the absolute simplest of lists that you will see. So this is going to be very similar to a vector in practice when it comes to indexing. So if we have this list, this is not nested. We're going to talk about nested lists, which is what you would see most often in practice with other lists. So we then want, how are the indexes here? So we are talking about the first value. So this is the first value in the list. And then this one could be kind of like, you could think of it, it's similar to a row name. So this is our first value in the list. You're seeing a 2 here because this is the second value, and this is the third value. This will make a little more sense when I go over nested lists. This derives from nested lists, and it's just a feature that lists have that will make more sense in this slide. So a lot of I remember in a lot of the use cases for lists, in a lot of JSON, when you put it, say you were, JSON is a data file type. If you were importing that into R, it would return a list from that JSON file. And why would you use a JSON file? Data dictionaries are often in JSON. Also, when you pull from an API, it's going to be JSON. So in general, Python is, I think, a little bit more useful for that kind of work. But you can do it in R as well. So if it's going to take that JSON file, and it would look, when you imported it, a lot like this. So what this is showing here is something called a nested list, which is basically a list within a list. So in this case, there are 3 lists that are nested within one list. So this is where it gets a little bit complicated. And you're going to see this and how it works here. So this first value is going to be list 1. So that will be To Kill a Mockingbird, Harper Lee in 1960. Then the second, so this first one listed, because that is the first, it's the outer list, so it's the driving list, you can think of it. That has Pride and Prejudice, Jane Austen, and 1813. And then this third, so you're seeing it here, has Gone with the Wind, Margaret Mitchell in 1936. So why would it do, so if you're pulling information, why would it come out like this? And in a way, it's very efficient. If you analyze it correctly, and you can actually use the JSON file. So say you got something massive. an example I'm working on is like pulling finance data from an API. Not all companies are going to have all columns. And then there are millions of data points if you pull it like over time. So what this allows you to do, because if you have a data frame, it will be shown as missing and it'll have to store a missing value in that data frame. It can then return something like this. So it only stores the values that are actually available. It doesn't have to put missing. So you could have 2 values here and 3 values here and 1 value here, and it wouldn't yell at you, basically. So that's what you would use it for when it comes to that. So that's a big use case there. It doesn't have to have every value. But back to this. So as I said, the 1 is list 1, 2, list 2, and it lists it first because it's the outer list. So now you can see that there's also lists within this list. So you're going to see here that the first value, so value 1 in list 1 is To Kill a Mockingbird. You can see that here. Another example, say list 1, value 3 is 1960. You'll see down here that list 3, value 1 is Gone with the Wind, and list 3, value 2 is Margaret Mitchell. So you can see how that is working, but there's one index, and within that index, there's another index, basically, is how it would come through. So how would you then index this? So I gave a very simple example and the one with the classic books, but I will show an actual like use case that you would do. You wouldn't probably use it for something like this. You would have a data frame, but a very simple example for the concept. So if you're going to refer to the first list within a list, you would use a so if it's not nested, so or to the first. Okay, this is about it. I worded this badly. So what this means is you want to refer to the first list, or I guess it would be the entire first list within the main list. Use single brackets. So that is a little bit more clear, I would think. So if you are referring only to this first value, it will work if you have double brackets, but it's standard to do it this way if you aren't referring to a value within the classic books. So say I want to pull the first list in this. So I'm showing what this would refer to here. So this green indexing, so it's the entire first list, so the outer list, or the list that was listed first here, the most outer layer, I would call it. It will pull To Kill a Mockingbird, Harper Lee in 1960. So, but because there are lists inside of lists, we would then, in order to get this to work, your first value, so the outer list, we want to look at 1, so this green part. When you're doing it a certain position within a master list, you use double brackets. So in this case, it's pulling the first list here, so the green part, and then within the first list, the second value, so Harper Lee. So if you do that, it's going to return this. So if I go into R, I have this example here. So this was the simple list, and this was the nested list. So in this case, classic books, like I said, this will be the first list within classic books. I wanted to give multiple examples. So we have our classics books list 1. Say you wanted to only pull out list 3. You would then pull out that entire Gone with the Wind part. However, if you wanted to pull list 1 and the second value within list 1 is I showed you in the PowerPoint, it would again pull Harper Lee, the first value in first list, and then the second value within it. So notice the double brackets when you're talking about a position within another list. So this classic books part, and this is another example, it's going to pull the third value from the third list. So if you come up here, you could look at it. It's the third list, third value. So if we print that, it's going to do 1936. We can see that that's the right one up here. So that is how you would do lists. I'm going to go over a practical example, but again, APIs are stored in JSON, which if you put them into R are going to turn into lists. And you would have to parse them using indexing. So I was a little surprised. I've been doing this in Python, but they don't really have a better way of dealing with this except for actual indexing. So it's the same way in R. So if you're dealing with that list that you've imported, you have to use this indexing. There's not really a good alternative to it that I've ever found, and I searched pretty thoroughly. Before I go over a use case, are there any questions about this, like the structure? Okay, so a use case, I told you about the APIs and JSON. Well, another use case is web scraping. So I'm gonna come down here. So I'm gonna go to this website so you can totally understand what I'm doing here. So as time goes on, I'm gonna give an example here. So I'm gonna open this up. So say you want to automate this table. If you scroll down, say we want this information here. So the total number of prescriptions in the United States in each year. So you see here those values. And then it's prescribing rate per 100 persons. We've actually used this data, but it was in form of county and state. It's in state level data. So you'll see here, if you scroll down that particular table, there's no CSV file for it. And actually, when I pulled, we've been using this a lot. If you go into this, there's also no Excel sheet here. So it's in a table on a website. What I would say, that I think that the way that they present this is kind of stupid. So most websites outside of the government don't do this. They'll just put a CSV file that you can download or put both. But when you're using with government level data, for instance, the Bureau of Labor Statistics, they're a big one. Something like this from the CDC or say Medicaid data, I saw it a lot too. They put a table on there and no source file, which from a private company you would probably never see, but with the government you do a lot. So say I am creating an analysis with this data here. Well, when 2018 data is available, they're probably going to add this here. But if you say, you could actually copy and paste this if you wanted to and put it in an Excel file and then import it. But when they added 2018, you would have to come in here and manually do that again. And you would have to figure out when it was released and know that you have to do it again, which is not efficient because things change all the time. Say it's daily unemployment data from the Bureau of Labor Statistics, that's going to change very frequently. And even if it isn't frequent, you don't want to have to go in and manually do something unless you have to. In this case, you don't. So what you would use for this is web scraping. So it basically pulls the data from the website that we were just looking at. So I'm not going to go over the particulars of this. If you want to learn more about what these values mean, you're welcome to go. It's up in the RVest package. So install that if you don't have it in order to run this code. So this is just going to pull the website data. I'm not going to go over this function and how it works. I can have a class on this later. And this is basically pulling all the tables if something is in a table format within the website. So now I'd like to show when you're looking at lists, a lot of the time it's helpful to use the structure variable or function. So it tells you basically the structure of our list here. So we have, just as we saw before, because, so if you go in here, is one table, two tables. There are only two tables in this web page. Say there are bunches and bunches and bunches of tables. You could then come in and I believe say view page source, and it's going to give you the HTML. Somewhere in here, it will specify that this style is a table. So then the R will know what is a table and what is not. So we can have a web scraping class, but that's all I'm really going to go over regarding this. But it now has a nested list, just as we saw before. So let's explore the tables. So table one, it's messy here, and we can fix this, but you're seeing here that this first table, so number of prescriptions, and then you see the numbers with the prescribing rates. They're going to match this first table. More on that in a second. So say you're looking at table 2, it's going to show the second table. So year here. So this is the per person, I believe so prescribing rate per 100 persons. So that's good. Table is going to match that as well. That second table. So that's showing kind of how you would do that there. You could also do say single brackets here and it would return the same thing. So that is actually the correct way to do this. So now it's returning 1 and 2. So now that's how you would explore this. So actually, I didn't notice this before. So there is an interesting, I think, with this type of list, since it's a nested list, we are getting a different result for the double or single brackets. I am not 100% sure why it's doing that. Because I would normally, you would see it as basically a list within a list. You could use that single value. I can put that on the Slack channel. But this is the structure to do it, and that's how you would deal with this list. Apologize for not knowing totally what you would do. So this HTML table, it's pulling out our tables, just like as we showed up here. Header equals true means it's keeping the column names, and then we're filling it, basically. But the same thing that we used here, we're putting, so it's pulling that table values exactly like we saw up here, those specific tables. And those are just arguments to say exactly what we want to pull, but you'll see indexing here at the end. So we want the prescribing rate, and then we have an index. And this will actually convert it to a data frame table format. So now we have prescribing. Now we have something that we've seen many, many times. And this will match exactly this here. So that's an actual use case that this would be used. This is very common in data science. A lot of people use this. So this is something you'll see very, very frequently. Are there any other questions about this before I move on? I wanted to show something that is actually like that a lot of people do in practice. I would say that Python is much better for web scraping than R. Are there any questions?
Yeah, I was gonna ask you how much you use lists. I have a guess on this, but I just was wondering.
So the two use cases that I gave, I would use lists every time because it's really the only way to do it. So hard like data science work uses JSON pretty heavily. So because of it's storing the data when it's really large is less intense than say a relational database because you have to have those missing values stored. So if you've ever heard of something called NoSQL, that's actually how you would store unstructured data. And the same thing, unstructured data means JSON. So you would in a lot of cases use that, and APIs are built in JSON, and pulling data from an API is really common. So when we pull that data, it's going to come in as a list, those JSON files. So if you look at job descriptions, a lot of them will have JSON and NoSQL written on there. So that's what we're talking about here after you import it into R. So APIs are a very common use case. And then web scraping is extremely common as well. I would say it's more commonly done in Python, but it's done in R as well.
Yeah.
So depending on how much your company uses web scraping, so if they're going to use government publicly available data, you're probably going to see this a lot.
Yeah.
Because again, it's usually government data where you have to do this.